Hello, I'm Volker from ATV. With this video, I would like to give a short introduction to our Measmatic software and how you can easily get a test done for a transistor measurement.
Let's start the Measmatic application. While it's loading, here's an overview of its core features. Measmatic is a platform for automated measurements. It is especially designed for the needs of semiconductor engineers. The software is developed for interactive operation, where the engineer does not need to have any programming knowledge, and supports an immediate and intuitive data visualization. Measmatic comes with a library of vendor-independent device drivers, but also allows experienced developers to program their own tests and instrument interactions with the built-in Python script support. When Measmatic is started, we have an empty project. First, we need to define a device driver connection for the instrument we would like to use. We pick the used instrument and define the communication interface. GBIP, RS-232, and TCP/IP are supported. Adding the interface address, and we are ready to connect. The next operation is selecting a test from a library we want to execute. In our example, it's a MOSFET test to measure the output characteristics of a transistor. We drag the test template to the sequence. We need to fill in the SMU assignments and test parameters, limits, and measure ranges. Now we have set up the test, and when executing it, we can immediately see the results in the diagram. Measmatic always shows the results immediately to provide the engineer the needed feedback to assess the data. The diagram settings allow us to make adjustments to the graphs, where the results spreadsheet show the individual data objects and measured values. In the definition of the output data, further calculations with the measured data can be defined. The following example shows how to determine the maximum drain current. This dataset then also is shown in the results. Besides single DUT measurements, Measmatic also supports various Waferprober systems. In our example, we now can add a device driver for an MPI Waferprober with SENTO. There we also define the interface to the probe system. And connect. In the probe station library, we have various commands to control a Waferprober. We add the sidestepping to our test sequence. The output characteristics is set as a subtest of the sidestepping. This defines the measurements are taken for each DUT when the Waferprober sidestepping loops over each test point on the wafer. We have already prepared the wafer substrate and map to run over 5 DUT on the substrate. Executing the test sequence by pressing the double arrow, Measmatic loops over substrate and sequentially takes measurement of each DUT. The dataset also contains the DUT row and column information. For running the same tests at a later time, the test sequence and all the parameters and settings can be saved as a project. In this video, I have shown how easy it is to set up simple test sequence and loop over multiple DUT. In the next videos, I will address some more detailed features as data processing and creating own tests. Thanks for watching.